All right, strap in, everyone. Today we are diving deep into, well, a cosmic flashlight, kind of. It's revealing these crazy hidden structures in space.
Ooh, I like that. A cosmic flashlight.
Right. And we've got this amazing article all about it, about what the James Webb Space Telescope is showing us, JWST.
Yeah, the JWST.
So this article is about a supernova's light echo and how we're basically getting a 3D map of all this interstellar dust and gas.
It's like a cosmic CT scan.
Exactly. So cool.
And the thing is, we're seeing this echo in infrared light, right? So that means it's the dust itself that's actually heating up and glowing.
Oh, wow. I didn't realize that. So the James Webb is actually picking up on, like, the heat signature.
Exactly. And get this, the supernova, the one that caused all this, that happened like 350 years ago.
Wait, 350 years ago? Hold on. You mean the light from that explosion is just now reaching these dust clouds?
That's exactly what it means. Isn't that wild?
It's like a time machine.
Totally. Showing us this ghost of an event from like way before any of us were even a thought.
Crazy. And, it's amazing to think that this is how we can even learn about this stuff. About the stuff between the stars, the interstellar medium.
It's usually totally invisible.
Right. Okay, so the article was talking about how the scientists were like totally shocked by what they were seeing in these images, and they described it as being layers like an onion.
Yeah. Layers like an onion.
So help me picture this. What does a cosmic onion actually look like?
Okay. Imagine all these crazy knots and these swirling filaments of dust and gas, and they're all lit up by this ancient supernova light.
Whoa.
But it's more than just a pretty picture.
Oh, I bet.
We're seeing this in infrared, right? So that means we can actually kind of see through those outer layers. We get this like three-dimensional view of the whole structure.
That's amazing. So we're basically seeing the inside of something that's been hidden for like centuries. And just because of the magic of infrared light.
I know, right?
Okay. And the article mentioned these super fine details that JWST is picking up. These filaments are tiny, like less than 1/100th of a light year across.
Yeah. And just to be clear, a light year is like a really, really long distance. It's the distance that light can travel in a year.
Right.
So 100th of a light year is still something like 600 billion miles.
Whoa, that's insane.
And these filaments, those thread-like structures, they're even smaller than that.
That's blowing my mind.
Yeah.
So we've got these massive clouds of dust and gas, but then they're like made up of all these crazy tiny filaments.
It really shows you how much structure there is in space, like all these different scales.
It's like when you zoom in on something that looks like simple and you realize it's made up of millions of tiny little things.
Yeah, exactly. And what's even cooler is that these tiny filaments, they seem to be arranged into these bigger, like sheet-like structures.
Sheets.
Yeah. And the article talks about how magnetic fields might be involved here.
Space magnets. Okay, I'm listening.
Right. Always a cool topic. So imagine magnetic fields as these like invisible threads running through all that interstellar stuff. And they can actually push and pull on charged particles. So they end up influencing how the gas and dust moves around and clumps together.
So it's like there's this invisible scaffolding that's shaping these huge structures.
Exactly.
Okay, that makes sense.
And some of these clumps, like these knots, almost look like wood grain in the pictures.
Oh, I saw those.
So those could actually be what are called magnetic islands.
Hold up. Magnetic islands. What are those?
It's like picture areas in these dust clouds where the magnetic fields are like super strong and tangled up that makes these dense clumps of matter form.
Like islands in a sea of dust, kind of.
Yes, exactly.
They're starting to get it.
They're still pretty mysterious, but now that JWST can see in 3D, we might finally be able to figure out how they form and what they actually do.
Awesome. And what about those sheet-like structures? Are those also formed by magnetic fields?
That's what the scientists think. Remember those tiny filaments?
Yeah. So picture them being like stretched out and lined up by magnetic forces. And that's how you get these huge sheet-like formations.
Wow. So we're literally seeing these fingerprints of magnetic fields on a cosmic scale.
That's exactly what it is.
That's so cool.
And the thing is, before JWST, we could only like guess about the structure of these dust clouds. But now we can see all these tiny details. And that's how we're starting to understand the forces that actually shape them.
That's amazing. And this is just one snapshot in time, right? I mean, the article mentioned that the team is doing multiple observations, like over time.
Yeah, they're going to be watching it change.
Oh, so it's like a cosmic time lapse.
I know. It's so cool.
I'm dying to know what they're hoping to learn from that.
Well, by looking at the same dust cloud, but before, during, and after it's lit up by this light echo, they can actually track how the energy from the supernova from hundreds of years ago is messing with the gas and dust.
They're looking for how the molecules change and even for signs that some of them get, like, destroyed by all that intense energy.
Wait, destroyed. So this supernova happened centuries ago, but its energy is still actively shaping things.
Yep.
That's wild.
I know. And by watching how these clouds change over time, we can get a peek into some really fundamental stuff. How matter is created, how it's destroyed, and how forces we're just barely starting to understand are constantly reshaping it.
This is already blowing my mind, and we haven't even gotten to the rest of the article.
I know, right?
Yeah.
It really makes you think, like, what if this kind of cosmic remodeling is happening all over the place, changing the interstellar medium in ways we can't even imagine?
Yeah. Like we think of space as empty, but it's actually this crazy active place shaped by all these invisible forces.
Right.
And the article even mentioned another telescope, the Nancy Grace Roman Space Telescope. It's going to be searching for more of these infrared light echoes, right?
Oh, yeah. The Roman telescope. That's where things get really exciting.
I bet.
It's going to be scanning like huge chunks of the sky, hunting for these echoes. And when it finds them, JWST can like swoop in and take a closer look with all its amazing sensitivity.
So they'll be working as a team, kind of, uncovering these events from the past.
Exactly. Like a cosmic tag team.
I love it.
Imagine the possibilities. The Roman telescope will be like the scout, mapping everything out, and then JWST will be the specialist, going in for the detailed analysis. It's a whole new era for astronomy,
It's pretty mind-blowing. This one light echo from Cassiopeia A is already incredible, but now we might be able to study tons more.
Maybe even hundreds.
It really makes you realize how much we still don't know about space.
That's what I love about it, Every new discovery just leads to more questions.
And with every piece of the puzzle, we get a little closer to understanding, like our place in the cosmos.
Totally.
It's pretty humbling. And speaking of understanding, I keep thinking about that cosmic CT scan analogy.
Oh, yeah, that's a good one.
It's crazy how JWST can give us this, like, multi-dimensional view of something that used to just be a flat image.
It's the perfect comparison. Think of a regular photo. You just see the surface. You have no idea what's underneath.
Right.
But with the CT scan, you see all the hidden layers and the complex stuff inside. That's exactly what JWST is doing for the interstellar medium.
So we're not just seeing a picture. We're getting a sense of, like, depth and structure. It's like going from a basic map to a 3D model of a city or something.
And just like exploring a city, the closer you look, the more cool stuff you find. These observations are showing us how all these structures are connected in ways we never even knew before.
So it's like this one supernova's light echo is giving us clues about the whole life cycle of stars and galaxies.
Exactly. It all ties together.
That's awesome.
The interstellar medium is where stars are born. It's like the raw material, the dust and gas for whole new solar systems.
Right.
So if we want to understand how the universe evolves, we have to understand the structure and composition of the interstellar medium and what shapes it.
Okay, that makes sense. It's amazing how everything is connected. And it makes you wonder, if magnetic fields can shape these incredible structures on a small scale, what about the really big stuff? Could they be influencing whole galaxies?
That's a great question, and it's something astronomers are trying to figure out right now.
I bet.
We're only just starting to understand how important magnetic fields are in shaping the universe. And with tools like JWST, we can actually observe these processes in amazing detail.
So it's like we're finally getting the tools to read the universe's instruction manual.
Exactly.
Love that. And it's crazy how JWST's ability to see in infrared is changing everything.
It's a game changer, for sure. Infrared light can go right through those clouds of dust and gas that block visible light, so we can see into places that used to be completely hidden.
It's like having a whole new set of eyes. Right?
Yeah, a new way to see the universe.
I love that. So the article mentioned that these infrared light echoes are actually really rare.
They are.
What makes them so special?
Well, you need a very particular set of circumstances. It takes a supernova that makes this really short but super intense burst of radiation, like a flashbulb going off.
Okay.
And then you need that burst to hit a nearby cloud of dust and gas.
So it's like a cosmic alignment.
Exactly. It's not just any supernova that can do this.
Oh, so it has to be a certain type.
Yeah. It has to be the kind that releases a massive amount of energy really, really quickly.
Wow.
And even then, the dust cloud has to be in just the right spot at just the right time to get lit up by that burst. It's kind of like catching lightning in a bottle, but on a cosmic scale.
Yeah, that makes sense. It makes you wonder how many more are out there just like waiting to be found, hidden in all that vastness.
Right. It's a cool thought. The universe is full of hidden treasures.
Yeah.
And now we've got these awesome new tools like JWST and the Roman telescope. We're just getting started, really.
It's incredible. This one supernova, this explosion from centuries ago, is still teaching us so much about the universe.
It really shows you how everything is connected, you know? Even in its death, this supernova is still affecting the interstellar medium, maybe even triggering new stars to be born and shaping whole galaxies.
It's this like cycle of creation and destruction,
Yeah.
but on a massive scale.
Yeah.
And we get to see it happen because of these amazing telescopes. Oh, and by the way, the images in the article are unbelievable.
Oh, yeah.
Yeah, if anyone wants to see these cosmic onion layers for themselves, we'll put a link in the show notes.
Definitely worth checking out. Sometimes you just can't describe these things with words. The beauty and complexity.
Right. It reminds you that science isn't just about, like, data and equations. It's also about awe and wonder,
Yeah,
pushing the boundaries of what we know and understand.
totally.
And this discovery, this light echo from Cassiopeia A, it's a perfect example of that.
It shows what we can do when we're curious and clever. We've been looking up at the stars forever, trying to figure out where we fit in. And with every new telescope, we get a clearer view of the cosmos. And of ourselves, too.
Absolutely. So to sum up, we learned that the space between the stars, the interstellar medium, it's way more complex and active than we thought. We're seeing these mind-blowing structures shaped by magnetic fields and changing over time because of the energy from a star that died a long time ago.
And this is just the beginning. We've got new missions coming up, like the Roman Space Telescope, and we're going to find even more of these light echoes, each one giving us a unique look into the universe's history.
I can't wait. It's a pretty amazing time to be into astronomy. So next time you're under a clear sky at night, take a minute to look up and really appreciate how vast and incredible the universe is. Who knows what secrets are hiding up there, just waiting to be discovered.
And remember, every single star has a story to tell, a story that goes back billions of years and connects us to the very beginning of everything.
So well said. Thanks for joining us on this deep dive into the mysteries of space. Until next time, keep exploring, keep wondering, and never stop looking up.